Good morning, good evening, and good day. Thank you so much for joining me today. I'm Joseph Moraes, Cloud Partner Solution Architect from Confluent, the company behind Apache Kafka. I am thrilled you chose to spend some of your very valuable time with me. Let's first discuss today's agenda, beginning with, at a high level, what is Apache Kafka and what problems does it attempt to solve? Who is Confluent and how do we relate to Kafka and how do we make it easier to run Kafka at scale? Lastly, we'll dive into 3 new features we added to Confluent Cloud this year and how they may relate to your company's outcomes. At its core, Apache Kafka is a scalable, highly available event streaming platform, which you can think of as the central nervous system of an enterprise. Kafka also makes it easy to get more value out of your existing systems and to make them real-time, so to speak. We're not going to get into the nitty-gritty details of how Kafka works. There are brokers, consumers, and producers, but you can find all that detailed information at docs.confluent.io. Let's instead focus on the core features of Kafka. In order to let you and your organization work with event streaming easily and efficiently, Kafka provides 3 main capabilities of event streaming: to publish and subscribe to streams of events, to store your event streams durably and reliably like a database, and to finally process and analyze your event streams. Often companies start their event streaming journey with publish and subscribe first. But to think of Apache Kafka as only a pub-sub messaging system is to think of an iPhone as just a device for making and receiving phone calls. Outside of the code, Kafka is also about the community. These numbers really speak for themselves. The community loves Kafka and Kafka loves them right back. For non-Kafka nerds in the audience, a KIP is a Kafka improvement proposal, which is used to submit propositions for major changes to open source Kafka. The strength of Kafka is not only its completeness as a streaming platform, but also the ecosystem around it. Kafka is not an island. Fun fact, there are 1,000 times more lines of code for integrations to Kafka than the lines of code for Kafka itself, and Kafka is no small project. How does Confluent fit into all of this? The founders of Kafka are the original creators of Apache Kafka, and the team at Confluent has over 1 million hours of contributing to the Kafka open source codebase and managing Kafka clusters at the largest of scale. At the time of this recording, we have over 6,000 clusters running in Confluent Cloud. Our platform extends Apache Kafka to be a secure, enterprise-ready platform, and we help enterprises all around the world successfully deploy Kafka at scale and accelerate their time to market. Because of the success our customers have achieved, we have won several important awards, including Forbes 100 Best Cloud Companies, Morgan Stanley CTO Innovation Award, being inducted into JP Morgan Chase's Hall of Innovation, and Bank of America's Enterprise Innovation Award. The largest, most innovative organizations in the world are partnering with Confluent and recognizing us as a key element of their success. In addition to the love we have for the community, Kafka and Confluent also love the cloud. To that end, Confluent has pushed forward efforts to make Kafka a cloud-native platform. So what does it mean to be cloud-native? Elastic, serverless, API-driven, all of the above are core tenets of making a data system cloud-native. Making Kafka cloud-native is one of the core goals of Project Metamorphosis, an effort Confluent launched this year in 2020 to make it dramatically easier for any organization to use event streaming to unlock new business, exceed customer expectations, and drive massive operational efficiencies. As we've discussed, Kafka is a proven distributed architecture for event streaming, but it is still complex to manage globally and tough to scale. Cloud-native systems let you harness the efficiencies of cloud, but they don't have the scalability, durability, or reliability of Kafka. Confluent is the only company that lets you leverage the power of both worlds. The 8 pillars of Project Metamorphosis are where we're focusing to continue our innovation and turn Apache Kafka into the next-gen event streaming platform. Confluent completes event streaming by adding features, support, and expertise on top of open source Apache Kafka, which makes it easier to build apps and run clusters at large scale. The world is moving from batch processing to real-time, event-driven architectures, and Apache Kafka is at the heart of this transformation. Operating Apache Kafka, a distributed event streaming platform, is not a trivial task, and it requires extensive Kafka ops experience. Confluent Cloud is a fully managed Apache Kafka service that simplifies the adoption of Kafka by completely removing the operational burden of managing it. As a managed service, Confluent Cloud includes uptime SLAs, and it can be easily integrated with cloud provider and third-party services with a strong connector ecosystem. Focus on building things instead of keeping them up and running. There are several Kafka services in the cloud, but only one is cloud native, Confluent Cloud. Let's review all the different components that make Confluent Cloud more than just a managed Kafka service. Provision a cluster instantly. No waiting around for the cluster to spin up or concern for a large operations team for large-scale workloads. Usage-based billing. No need to spend a penny more than you have to. You will always be on the latest version of Kafka. Did we just upgrade your cluster with no downtime, interruption, or performance degradation? Yep, we did. This slide speaks for itself. We've gathered data from our customers on both the total cost of ownership and velocity related to hosting your own scaled Kafka deployment. Confluent Cloud shrinks deployment times in comparison. For some objective data, according to a 2020 tech employment survey, Apache Kafka was the most highly demanded tech skill with an average salary of over $134,000 and a 5.5% year-over-year growth rate. There was a 38% increase in job postings requesting the skill in 2019, with more than 30% of software engineering job postings requesting it. So I mentioned you could provision a cluster instantly. Now I'm going to put my web browser where my mouth is and demo it for you.
All right, so I just wanted to show you guys how easy it is to create a cluster in the Confluent Cloud user interface. So both of our basic and standard cluster types are instantly provisionable. So we just got to pick a type and the availability. Do we want it in multi-AZ or do we want a single availability zone? I'm just going to pick single zone for this demo, and then we hit launch. And just like that, we have a cluster. I know, incredible, right? So let me walk you through how we can interface with it. So in this case, I already have the CLI installed, so I'm going to skip this particular step, but I'm going to run through the rest of these. So we're going to update to make sure I got the newest version. All right, we're going to make sure that my login is saved. This should already be ready to go. All good. We're going to select our environment. So think of an environment as a collection of clusters. So you could have, in my case, my environment is named after me, but this could be dev, staging, test, and production environments. And then you could have collections of clusters underneath there. All right, and then we're going to pick the cluster that we want to use. This is going to be the cluster ID of the cluster that we just created. And then I'm going to create a new API key for this. This will not be relevant by the time you actually see this, so you can copy this down all you wish. This cluster will be gone at the end of this demo. So we just need to pull in this. We'll use this key. And we'll finish with the command right here. And we should then be authenticated. Awesome. So first thing we're going to do is going to create a test topic. And we can verify it's there by running the list command. Cool, was good. And then let's start producing messages to the topic. So we'll do that using this command. So message 1, message 2, message 3. I might have went a little too fast there. All right, but we'll get this back. So, and I also want to grab this command here. So this is the topic that we created using the CLI. And I can actually show you us create messages in real time. See, we should start to see things up top here. There we go. This is what we would expect. So, and 5. So as you can see, we created a cluster very quickly, and we're already producing to it. And then the last step is, I'll show you how consumption would work at the CLI. So there's a command right here. We're going to consume from the topic. The -B is going to say, I want everything from the beginning. And what we should get is all of the messages. There we go. And we didn't quite get them in the right order just because of how I inputted those. But here we are. So I hope you got to see how easy this really was. And just to close out, I'll show you how easy it is if you wanted to. If this was, a dev cluster. Don't do this with production, but you could easily delete this. Voila, instant on cluster.
We have made a multitude of announcements since our last session at reInvent 2019. But I want to call out some of the most recent features we added to Confluent Cloud to make Kafka even easier. We saw a version of this slide earlier, but now let's focus on the infinite pillar. What does it mean to make Kafka infinite? Confluent Cloud is a completely serverless Kafka offering. Compute power and storage are completely decoupled, which ultimately allows us to provide scalability, efficiency, and the ability to retain events in Kafka theoretically forever. Another fun fact, the New York Times stores all their articles and related assets since 1851 to a single Kafka topic they call the monologue. So what are the cases for infinite? What are the use cases for infinite? Infinite retention allows you to completely reimagine what event streaming applications can do, as you can now build applications that leverage both real-time and historical events through Kafka. Consider machine learning data sets or even clickstream data. What types of insights could you pull from having data go back as far as you can imagine? You are going to have to answer that because I am not that creative. But for whichever of you are listening to that sentence and thought, aha, I'm talking to you. Also, have an amazing night's rest by leaving all the operational burden to us. Do you really need to determine if your topic is going to run out of space anytime soon? Not with Infinite. So you want to store events forever. We can help. I would like to introduce Senior Director of Developer Advocacy at Confluent, our very own Tim Berglund, who cannot wait to tell you about Infinite Kafka on Confluent Cloud.
Hi, I'm Tim Berglund with Confluent. Let me create a topic here called Russell 3000 and give it infinite retention, so data will never go away from this topic. Now, Russell needs some data in it. We'll set up a data generator to fill it with simulated stock quotes. Note well, I don't have to think about provisioning storage or even growing the number of CKUs allocated to this cluster like I used to have to do. Realistically speaking, I cannot outdata this topic. The administrative work required to handle all this data would normally be daunting, but Confluent Cloud Infinite Storage takes care of it for me. And as usual, I pay only for the data I send to the cluster and store in a topic. That's because, brokers, replicas, storage, a fully managed Kafka service really should abstract all that away, which is exactly what Confluent Cloud does. And because of that, while I'm generating all that data and retaining it forever, I can go see to my chores. Now then, at this point my cluster has 1 petabyte of data in it. That's 3 petabytes if we counted replicas. And I didn't exactly work hard to make it happen. But with a topic this big, certain kinds of consumer access patterns can be a problem. If you've got multiple consumers reading a topic, which is a perfectly normal thing to do, you can run into inconsistent performance if some consumers are reading old data and others are reading from the newest data in the topic. Those lagging consumers can interfere with the caching of the hot set of data being read and written by the consumers that are caught up. Now, this is not a thing you have to worry about with Confluent Cloud. Let me show you by starting 2 consumer groups on our massive stock quote topic. The first consumer, which is just a perf test, is reading from the beginning of the log, and the other is reading only the latest events. We see that despite the consumers reading from different points in the log, throughput is relatively consistent on both groups. You'd normally expect the lagging consumer to slow down the up-to-date one, but we just don't see that happening here. In fact, we see the lagging consumer is even faster, so it'll eventually be able to catch up. So, Confluent Cloud, no storage limits, all your data in one place, pay only for what you store, and do it in a performant way.
Thank you so much, Tim. I could not have done a better job. Trust me, I tried. Our next 2 features both fall under the secure pillar. Security is a very important topic, no pun intended, at Confluent, and as a result, Confluent Cloud provides encryption for both data at rest and in motion. Confluent Cloud also has control mechanisms in the form of SAML-based or single sign-on, roles-based access control, and access control lists, or ACLs for short. Our products are SOC 1, 2, and 3, ISO 27001, PCI, GDPR, and HIPAA compliant, Finally, we have private networking options available, one of which, AWS PrivateLink, will be the focus of this next session. AWS PrivateLink is a service that provides secure network access between virtual private clouds, or VPCs. At a high level, you drop an elastic network interface, or ENI, in each of your availability zones, which provides your computational resources, like applications running on EC2 instances or containers running on ECS, a dedicated endpoint to access services running inside of another VPC. In the case of Confluent Cloud, a private VPC that we set up just for your dedicated clusters inside of our AWS account. Many companies face limited private IP space, especially after years of M&A activities or eventual growth, which makes VPC peering a challenge. PrivateLink eliminates this using NAT, or network address translation, to translate source and destination traffic at the endpoint itself. With VPC peering, two-way traffic is possible. Though highly unlikely, unwanted traffic could theoretically initiate from Confluent Cloud into your VPC, assuming ACLs and/or security groups were not ideally configured. This is impossible with PrivateLink. All traffic must be originated from your VPC, and you can set up policies on the endpoint to govern which of your resources can and cannot access Confluent Cloud. So your network team is not very keen, that rhymes, on reserving blocks of IPs for accessing third-party applications, or perhaps the security team forbids publicly accessible endpoints to data services. In this demo, I'm going to show you how easy it is to self-provision an AWS PrivateLink endpoint to access your dedicated Confluent Cloud cluster privately and securely.
Okay, so in this demo, we're going to add AWS PrivateLink to one of our Confluent Cloud clusters. So in this case, for our private networking options, you're going to have to pick a dedicated cluster type. You could do single zone or multi, and you have to pick a CKU. And this is basically a unit determining the relative cluster size of a dedicated cluster. We're not going to really get into that today. But as you can see, one of our options here is PrivateLink, and I would pick this, and I would hit launch, and our dedicated clusters can take anywhere up to 24 hours to build. I've never actually had it take that long, but they could. So now we're going to wait. Just kidding. I'm going to do that thing that they do in cooking shows where they build something really nice and they go, okay, now we got to put it in the oven for 30 minutes. And then they reach in, they pull out, and it's already done, right? I'm going to do that because I do have another cluster right over here. All right. And what we want to do is we want to hit add private link here, right? So there, in the networking settings, you can add private links to this cluster, actually to multiple accounts. In this case, you already see I have one set up. This is what the interface looks like. You plug in your AWS account number, and then you're given the name of the endpoint to then set up inside of your AWS account. So in this case, I've already did that because there is a little bit of lag when you do this before it's ready. So we already have this. I have my AWS console here. So we need to grab this VPC endpoint name. We come over the VPC to endpoints and just make sure you're in the same region. Create the endpoint, find my name, paste that in there, hit verify. Found the service name, and I can see that this private link is associated with 3 of my availability zones that I have my instances in. And now I can, once I hit create here, I now have an endpoint in each of those, an ENI, that I can connect to and get private access to my Confluent Cloud cluster. There is one additional step here that would require a little bit of DNS work, but we're not going to go into that for this demo, but I wanted to show you how easy that was.
With PrivateLink set up, you and the network engineer can go back to being Slack buddies now. Bring your own key, BYOK, also known as customer managed keys, help customers put an additional layer of security for at-rest data on dedicated clusters. By default, all data in Confluent Cloud is encrypted, and for dedicated clusters, customers have the option to use either automatic encryption, which uses Confluent managed keys, or they can set up their own customer managed key. Both of these avenues leverage AWS KMS. I know, that first point is pretty dubious. Why would AWS or Confluent share my data? Well, there are circumstances where governmental agencies, through subpoena, will require a service provider to turn over information. In a situation like this, we could only provide encrypted data that only you can decrypt with your customer's managed key. Be compliant and keep the auditors happy by assuring them that though your data is hosted through a trusted third party, it is secured using a key owned by your organization. I am now going to show you how easy it is to provision a customer managed key in your AWS account and grant your Confluent Cloud cluster access to it to use it to secure your data.
For this final demo, we're going to start in the AWS console at the KMS service. We're going to create a key because we're going to need to plug in the ARN of this key during our Confluent Cloud cluster creation. So I'm going to pick all defaults for this demo. I'm going to call this BYOK_demo. I'm going to hit next, next, and then finally finish. I'm going to plug into here because I need that ARN. So again, this time we're going to go with a dedicated cluster. And here we're going to choose for encrypt data at rest. We're going to set it to self-manage. We're going to add the ARN here. All right, great. And we're going to need to pull some permissions that we're going to add to the key to allow Confluent Cloud to use that key to build the cluster. So here we're going to switch to policy view for the key. I'm going to edit. Hopefully I pick the right spot here to put a comma and paste and hit save changes. Yes. So now the proper permissions are in, and we do that, and we hit launch. And that's it. At this point, what we've done is we've asked Confluent Cloud to build this cluster using this key in your account, or in this case, my account. And it's because it's encrypting all of the volumes, it has to do that upon creation. So now I completely control that master key, and if I were to revoke it, this cluster would then become useless. I hope you found that helpful and useful.
I feel better about my data already. Just a quick look into the future of Confluent Cloud with some new features for 2021. Shrink your cluster. Easily scale your cluster down to the right capacity for your workload. Policy-based scaling. Set your cluster to scale up and down automatically based on utilization. Data lineage. Know where your data is coming from, where it is going, and what transformations are applied to it as it flows through multiple processes via the Confluent Cloud UI. So I have said a lot about how Confluent Cloud makes Apache Kafka easier, but don't just take my word for it. It is my pleasure to introduce Wei Manfredi from Lululemon and John Vines from AO.com, who are going to discuss their experiences and outcomes building applications using Confluent Cloud on AWS.
My name is Wei Manfredi. I've been with Lululemon for almost 3 years. Lululemon is a yoga-inspired sportswear company, and we're growing globally. Currently, we have 500 plus stores in every continent. And I'm responsible for global enterprise architecture and the integration platform. One thing we immediately realized is the real-time importance of the information across globe. How do we enable information globally and in real time, and also democratize information or events to entire company and our ecosystem partners? And when we look further, we find out the current integration platform we have is not going to scale, and it's not going to enable the real-timeness of the information flow. For us to enable event streaming quickly and also lift up those business capabilities that we are aiming for is the #1 priority. So Confluent is definitely the #1 provider in the Kafka event streaming in the industry. We use S3 to store historical log information using the S3 connectors, of course, right? And then we also built a bunch of custom connectors, and they were using EC2 as a host environment. So the benefits of that is essentially most of our developers, they are AWS savvy, right? It's a no-brainer for them to leverage that cloud platform capabilities. And second is actually, a little bit cost-saving opportunities there as well. As Lululemon is a vertical retail company, we deal with many manufacturers and partners globally. And the purchasing order system, and of course, traditional one is a file-based. It's not reliable. Second is the speed is an issue. So the first thing we thought is to try out the event streaming so that any changes made by us or our partners can be visible to both parties. As majority of companies start from the retail, from store side, and then growing really quickly on the digital, Unfortunately, in the back-end system, those are two separate technology stack. So in order to make the inventory visible to all selling channels, that's like, no-brainer for all, right? And not only the customer experience, also be able to maximize our inventory.
My name is John Vines, and I'm an engineering lead and part of our data leadership team here at AO.com. AO.com is one of the UK's largest online electrical retailers. From a technical perspective, we wanted a cloud-native, enterprise-grade infrastructure that would allow us to combine historical customer data with real-time digital signals from our customers as well. And we wanted it to be able to use that to deliver highly personalized customer interactions effectively on site. So being able to use that data as it's happening within the context of the organization. There was a desire to move into Confluent Cloud because that gave us a fully managed solution for Kafka as a whole. So that gave us a number of benefits, including reducing operational overhead within the team and maintenance of those clusters, allowing the team to focus on delivering value and removing undifferentiated heavy lifting effectively. And that in turn helped us lower the total cost of ownership of the team, and what we were trying to deliver became business value giving rather than maintaining a Kafka cluster alongside it. Having Confluent Cloud on AWS has allowed us to achieve quite a few things. Our biggest use case at the moment is giving us real-time access to clickstream events as they're happening. From a business perspective, that gives us that opportunity to have kind of a real-time contextualized, personalized use case, which in turn has demonstrated a conversion uplift and a revenue uplift as well. The big opportunities that we've realized with both having Kafka as a managed service and the AWS managed services alongside that as well is that we can take advantage of the scalability that those cloud native approaches to building our applications gives us. So being able to respond not only to what a user's doing, but technically being able to respond to traffic levels as they go up and down, or specific events as they happen throughout the year, such as Black Friday. The big benefits that we're looking at from an architectural standpoint means that we can start to kind of formally share data across the organization with our events, with the contracts defining schema registry. That in turn aids things like discoverability and governance and that kind of stuff. But the big thing is giving us an ability to decouple application architecture, modernize where appropriate, explore new opportunities where possible. We can start to integrate with a number of existing applications using Kafka Connect, taking data from places like SQL Server, from MongoDB, but also start to create new application footprints with some cloud native options in AWS, including technologies like Fargate, Lambda, and S3. What we can do with Confluent and what's available in AWS has been some of the biggest benefits that we've seen.
Wei and John, I cannot thank you enough for sharing. Speaking of thanks, thank you again for learning about Confluent Cloud and for putting up with my antics throughout this session. If you're watching this during reInvent and not weeks later, then please come join us in our virtual booth. You and I might even get a chance to chat. For any time though, check out Confluent on the web at confluent.io, on Twitter at Confluent Inc., or on the AWS Marketplace using cnfl.io/AWS2020. If you enjoyed the session, or even if you did not, please consider completing the session survey. Wherever you are, whenever you are, I hope you have an amazing day.